Doing good health. Awesome. Oh, I'm doing good. I'm doing good. Thank you so much, Diptesh, for asking. Just a question. All of you folks here today are which year students? Can you just type whatever your third year students? Okay. Wow, that's great that you're getting head start on getting this exposure. Second year, awesome. Just to give you a background, Ronak and others who said second year, I started planning my final year project in 95, 97 for and getting my proposed team when I was in the fifth semester itself, because I had a really shitty idea at that time to do a project. I started saving up for it so that I could actually buy the equipment and things to do it. So it's a good head start you got for those who are in the second year to get exposed to all these wonderful tools. Aerospace engineering, awesome. Abhi, look out, I'm going to show you a case study later, academic case study of a single winged aircraft. It's called a maple leaf monocopter. I'll just show you the case study. Maybe there's a link there also on that you can check it out, or you can write to me. I can send the link later for those of you who are interested in the aerospace. Yeah, great. So it's 9. I think can we just ask the host whether we can get started or?
Yes, sir. Oh, well, good morning.
Good morning. Thank you.
So, sir, we can start.
Okay. If everybody is able to see my screen, just give me a shout and.
Yes, sir.
Yeah. Okay. So we have a lot of content to cover today in small bits. So I hope you're all energetic, have your water and snacks next to yourself so that we don't go around and miss anything. And so in the interest of recap, I would rather leave the forum open to any questions or doubts apart from just software operating. If there's a software operation issue, send it out to my team. They'll help you to do it. If there are any other questions that you have, I'll be very happy to answer here as we get ahead. And if there are no questions, we'll get started. Where's the chat box? Where's the chat box? Yes, let me drag it. Oh, visible, great. So, is there any questions from your side, or do you recollect what we did yesterday? We did two very detailed sessions on using the DFM concurrent costing tool to analyze a part at a conceptual level, the idea of a part at a conceptual level. We did some detailing of what if scenarios. If you remember, what if I change the batch size? How does it impact? What if I change from a certain profile, let's say an automatic machine, to a different machine? What if I change the profile of the actual die casting machine by selecting a different die casting machine? And then we did a copy of the idea that he had for the part by actually importing a CAD model. So he showed you how to do a CAD import based analysis, and then how to refine that CAD import based analysis, and so on and so forth. So I showed you the whole gamut of how, if you're in the industrial engineering or conceptual design stage, right up to doing a detailed costing stage. And then my colleague Balaji showed you how to do a PDF based drawing or a drawing based analysis of a sheet metal part. And then I followed it up by showing you how a CAD based import a sheet metal part. In all of these, I showed you how the geometry calculator, a very important constituent of the DFM software, which what you need to know is that the geometry calculator will come up differently for the different commodities that you pick up. And what is the meaning of commodity? Can anybody shoot out on the chat? What does commodity mean? Remember, we spoke about tips, part, and rather, Ashwin, it is process and material combination. That's commodity. Process and a material combination. Okay, we'll use that term as commodity. All right. So thanks so much for being proactive. I should appreciate it. So can we get started with the looking at a DFM of a plastic part? Empirical formula. Okay, Balaji, are you going to do the plastic part? Are you there?
Yes, sir. Yes, sir.
Can you get started? What I'm going to do is I'll just take a Word document and type this out. I already had it here. Actually, my other system has failed, so I'm going to type it out here and put it up. The empirical formula. I thought we already sent these answers, but I think we've not. Can we do a cost versus time analysis for optimizing the output by using the same file in DFA and DFM? See, what is the definition of optimizing cost and time analysis, Bagul? Of course, one thing is you can use the same file. That I'm going to show you this. If you see my screen, I've talked about DFA and DFM for total cost, right? This item number 4. Here, what I'm going to show you is if you've done a part in DFM, how you can bring it into DFA, or if you had an idea of a part that you wanted in your product in DFA, how you can link it into DFM to get a part level costing. We've done that actually on day 1 as a part of my demo, but I will show it again today. Okay, just look out for that. Empirical formula. Yeah, Balaji, are you going to? Can you take the screen share? In the meanwhile, I just type this. Or how's that you want me to do? Balaji?
Sharing my screen.
Awesome. Let me just get out of here.
Because today now we can look for plastic session, DFM for plastic. Now I will show how to import a CAD model and we can do for plastic DFM analysis. So I want to import a CAD model. First I want to go to external CAD model, load, or you can go to this icon of a solid block icon, load CAD. You have to press that and click base.step file. Any format which is STL step or IGS which can be imported in a DFM file. So using the part we can now do for a plastic. I will give us 10,000. Gives like hollow block. The forming direction I will choose as the y-axis. Click search for material. Go for injection molding. If we select the process of injection molding, and the default manufacturing profile of BDA North America, it shows only 2 materials. It is built reinforced plastic and plain resin thermoplastic. So ABS is a good engineering plastic. We can choose ABS with injection molding and click OK. Part volume is shown in a yellow orange color. It's imported from a CAD model. So as of now we have done primary operation. Now we have to do for secondary operation. Like we have to insert a machine tool setup. To drill a hole in a part, we have to do for secondary operation. Like I can choose a generic drilling center machine and click insert. I want to drill a hole. So under insert of the machining, these are the Options are there. I will choose drill single hole, or you can choose drill multiple. For sake of presentation, I will choose drill single hole. So diameter of drill hole. In this geometry calculator icon will be there. Just click that one. So we have a CAD model. So just you have to load that and we can take a value. Length of edge segment in CAD model, you have to click that icon. Just rotate this. So rotating icon, just rotate this one. Now we have to drill that bigger hole. This one, this one hole is there. So keep it as one repeat count and give OK. So diameter of the hole is taken from a CAD model, and we have to go proceed with length of a drill hole. Length of a segment, same process. Length of a segment CAD model. This is the length. We can choose that one and give OK.
Balaji,
Yes, sir.
in this version, there's a correction, man. The diameter, no? If you
Yes,
click
sir.
on the geometry calculator, we have to take one segment of that, so not both. Just take one segment. Maybe again, and yeah, because the new version that I'm showing has this is the latest version copy which they have. And
Okay.
here what you should do is after you do that, you have to take the X, Y, or the Z as a dimension. In this case, you take the X as the marker. Guys, do not get confused with what I and Balaji are talking. Select on the X, Balaji. The distance is on top, yeah. Yeah, that will give you the diameter of the hole. This is diameter, no? So yeah, only one segment you have to take. Anyway, this problem is solved in the 2020 version, 2021 version. I will explain this geometry calculator maybe when I take example on the machining example.
Okay.
Yeah, because remember the part is only 100 mm. You can't have 145 mm diameter. 100 mm part.
Next, we have to drill multiple holes. Diameter of drill hole, length of edge segment in CAD model. So these two to drill. So I taken as a multiple hole. As I am having those, so as SAT told, we can select only one.
So what you're actually doing is you're selecting one portion of the arc, okay? And if you look at this on the bottom left-hand corner, you see the XYZ plane. So along the X plane, if you select on the right-hand side behind, that total length, there are three options there. There's an actual diameter length, and there's an X length, there's a length along Y, there's a length along Z. Just for the interest of the audience, Balaji,
Yes, sir.
click on all of them one at a time. Let them see the perimeter at the bottom. See, in Z it is showing 0. In Y it will show 0. In X alone it will show the dimension. So click on X. Go slowly because it is a little slow. Lagging is there. Click on X. This is actually the true. This is the actual true diameter. Now this problem, what Balaji is showing is the 2019 version. That's what he has on his laptop right now. So this is solved in the 2020, but just know that you're taking the diameter, which is showing on the left-hand side, bottom left-hand corner, diameter of the hole is taken from there.
So we have to give repeat count as 2.
No need. It's the diameter.
No, sir, it's 2 was going to drill simultaneously.
Correct. You will do that leave that as 1. You have selected to drill multiple holes, correct?
Okay, sure.
Leave that as 1. Repeat count as 1. Okay, so he has selected the diameter of the hole. Click on it.
I have to choose length of drill hole. So 2 identical holes are I want to take another option. These 2 holes I am going to drill. So length I am going to capture from the two holes.
The length is captured at the bottom.
This 2 repeat count now is number of identical hole drilled is 2. So as I said told, without repeat count, if we choose drill single hole, we can give 2 repeat count. We have chosen drill multiple hole now. So number of identical hole drilled is 2.
And one more thing, Balaji, it's okay. I think we get the drift. Can we go to the process chart, Balaji? So if you see here on the left-hand side, you're having single drill hole, multiple hole, right? Normally, as a part of DFMA, what we would do is the definition of DFMA, ladies and gentlemen, maybe this is another tip that you want to record. It is a systematic procedure to analyze and quantify product design. I'll repeat. DFMA is a systematic procedure to analyze and quantify product design. Those institutions and companies that have adopting this systematic approach are able to quantify their designs very well and find different ways of making improvisations. On the same lines of thinking, like when I'm building this process chart, imagine if this was a product that had multiple such holes and features. Okay, it'll just be drill hole, multiple hole. So what we normally would do is, if you're in a company, you have a process chart that you follow, you would actually have titles for each of them. For example, in this case, I would probably title the first drill hole as, but you can click on the drill hole in the process chart and call it dash center through hole. Next, multiple through, you can give it a name under that after it. So every time you get a process that you're including, make sure you know or you identify it uniquely. But you may say, sir, what is that? This is only a project I'm doing in college. Maybe you understand it. Let us say you look at the same project 2 months from now. It's the same project, you send it out to somebody who has to review. It should be easy for them to review it and understand, oh, okay, this guy is taking this feature from that drawing and that's what is marked here. So that systematic procedure includes, having your process sheet identified very well. And that's how you'll find probably a faster success when somebody is reviewing the process sheet, which they have maybe already existing manually or otherwise, and comparing your DFMA documented process sheet. I hope I'm making sense. If I make sense, please say yes on the chat box. If you don't, you can also ask me a question. Wonderful. Thank you. Yeah, yes, Balaji, please just continue. Let us, I think they get the idea of how. Now, one more thing I'd like to tell you, Balaji, go back to no. Keep your system on. Keep your CAD model on. Wait till I say I'm done and then we can come off. Now, if you look at this part, can you open the CAD model, Balaji? Please save this file. Don't delete this file. Save it if you want to come back to it. If you look at this part, ladies and gentlemen, it is a injection molded part. Can you move the CAD model aside, Balaji? Come on, move the CAD model view on the side. I want to see the life volume and all those details. Yeah. So now, if you look at a volume like 10,000 pieces, normally the features which just now Balaji showed as drilling holes and all that with the names would probably not be actually a secondary operation. You would actually get these parts, these features done as a part of the injection mold itself. Okay, but just in the sake of interest of this demonstration, he has done this, showing that what if you want to drill secondary features. That is what this objective of this demo is. I hope it's making sense. Which for a plastic part, these kind of good features can be precise molded in the injection mold itself. Making sense? But let us say if you're not doing it, you want to just make one part. Balaji, can you do a copy of this one, and make a material selection as nylon? First of all, save this. Rename the part as base dash nylon. Yeah. And go to the top first level and make the quantity as 10 parts, life volume. And select the process and material as machining. Yeah, full analysis. Great. Take nylon. Ladies and gentlemen, what we're showing you today is I have a part idea. I'm exploring for casting. Then I realized, oh, I only have to make for a prototype at my college. I don't have to make 10,000 pieces. What do I do in such a situation? Then you can just take the resin. You don't need to fill the plastic. It's expensive. You can just take the nylon in the next one. Plastic, plain resins. The next one. No. Come down here. Yeah, that one. It's a plain resin. Yes. I want to just machine 1 or 2 parts for my project. I don't need to make 10,000 pieces. You have a decision to make like that. So I'm just doing another alternate material. I could also do it with ABS, but yeah, okay. So it is asking you to switch. It's switching the data from your previous selection of ABS and injection mold to the new one. So it's asking you your permission. You say yes. Now you have an entirely different approach to looking at the same rectangular cuboidal part, and you start machining it from a block of nylon. Making sense? So what I'm showing you is the strength of the tool, that you have an idea of your product. Then you said, I can't injection mold. Imagine if you have injection mold this plastic component for a very small volume, you may have a challenge of having that. Go back to the other file. Go back to the other file base. If you see the tooling investment at the bottom, can you highlight Balaji? Tooling investment at the bottom, 19,300 below. You see, $19,000 or whatever is the amount you have to spend on that mold cost, and you may not want to do this when you want to do prototype, right? So when you want to make smaller quantities. So this kind of decisions, business decisions or design decisions that you may have, you can quickly resolve it by using other commodity opportunities. That's what we're showing you here. So go back to the nylon, Balaji. So as you can see, what we have done here is we have retained some of the machining steps from the previous exercise. That is the generic CNC machining. It is valid for a part like this. But the previous primary process is changed to a stock process. Can you go below for the next slide? On the stock process. Click on it. You see the data from the CAD software is automatically come and highlighted in the part volume in orange color. Okay. You go to the next piece, the next item. Again, let me go back. Sorry, go back to that stock process, Balaji. So you have 10 pieces. It is selected a batch size, showing it as 1. And it's also highlighting as yellow. Maybe if I want to make 10 pieces, it's a bad idea to make one at a time. Okay. See, the setup cost is so high, 3.75. Can you see on the bottom left-hand corner in the cost results? So a logical or a better solution would be, if I want to make just 1 piece or 5 pieces or 10 pieces, it's better to do all of them in a single setting. So I would rather change the batch size to 10. Can you do that, Balaji? Now calculate, see the impact. See the costing from $5 total, it becomes less than $2. So please know that you will have a rapid feedback quantification of your design intents. So when you have your ideas charted out on the left-hand side in your process sheet, review it one by one. If you want to sit with an expert who knows how this process has to be done, how this commodity has to be done, he can contribute well. Go line by line item, and that's how you'll probably get a very good, accurate result of your prediction. Why? Because the systematic approach is what will help you to solve. Any of these elements can drive the cost. Just know that. Yeah. I hope it's making sense. Do we have to make a decision to change material when producing a large scale, or is it already decided by the customer? Difficult to tell. It is depending on how you want to, what kind of a customer you have. See, from a business perspective, there's a WTP, willingness to pay. Okay, from a customer's perspective. So who's that customer, and what profile is he? So that decides a lot of these material and process selections, which is usually a business thing when you're a part of a company. Okay, and then what kind of a life you have that you're warranting the product. If you're giving a product which has 10 years warranty and it has to be in the sun, like a car, you have to make sure that you have good choices of good materials, good quality and resilience to heat and weather conditions, right? So these kind of things will drive how you select these parts and this component, these changes. This doesn't happen on the fly, but just know that this is the impact that you can create when you make these different choices. Making sense? Can you summarize what you explained about what making decisions on materials? Ekansh? Somebody understood? Can backtrack and tell Ekansh what we understood? See, your colleague Shanmukha Teja is asking, do we have to make a decision to change material when producing in large scale, or is it already decided by the customer? What I am saying is, depending on what the product is experiencing in its life, in its operational life, you actually have a choice of materials. But whether you change that material because the volume has become large numbers or not, depend on other factors, not necessarily only decided by the customer. Making sense? Okay. Nevertheless, for your own projects, probably you will want to choose materials and processes which are more suitable for small volumes, like one prototype, maybe up to 10 pieces. Okay, maybe that's a decision you may want to make when you're doing academic-like projects. But know this, that this is an industrial grade solution, that these kind of decisions can drive the impact of your selection of the material. Shall we go on to the next process? There might be cases when a product is produced only with an injection mold and no machining. Yes, very possible. Very complicated plastic parts, consumer products, office products, which have multiple features, are usually done with the injection mold. It is not a good idea to make it in machine. We cannot compromise on the material if it's for industrial purpose, right? But it's a decision you want to make. What is the definition of compromise? I will show you in the last slide when I show my case studies. Companies do what they call benchmarking. Hey, how come the fellow is making our competitor is making cheaper vis-a-vis ours, which is expensive? Then they compare. For even doing comparisons, you can use a tool like this. Then you see, oh, I'm using nylon, he's using ABS. Oh, I'm using 3 mm, he's using 1.5 mm, that's why he's cheaper. Oh, I'm doing machining one at a time. He's invested about 20 lakhs in an injection mold. That's why he's getting more precise products. You want to make these kind of competitive decisions. So compromise, trade, benchmarking, trade-off decisions. All these is a part of a decision-making process. When you're a part of industry, you get a flavor of all of that, depending on what kind of an industry you are, what kind of a customer you have, and what kind of a product you are building. Okay. So we go on to the next one. We have quite a few interesting things to do for the day. Balaji, you can take the drawing thing and I'll help you like this. Do you want to do that? You can save this and take up the machining part sample.
Machining part sample I'm not having.
No, the sample drawing.
Sample drawing, okay.
You want to do that? I think you should. First, let's take up the drawing, Balaji. Now let us do something like this, wherein we're going to treat all of the participants here as if they're going to be a part of a decision making used for a machine part. The machining exercise has already been given to them, right? They can do it at their own leisure. Let us take a simpler part for analysis now. Do you have the drawing? Not this one. The drawing which we have to do as a demo. Ladies, what this exercise is given to you. You will probably do this exercise at your free time. But for the demonstration purpose, we have a simpler drawing. The image has been given to you. Do you have this image? Balaji, I think. Okay, Balaji, can you stop your sharing? I will take it from here. I'm not able to see your screen. Organizers, can you help me to share my screen?
Just assigning you, sir.
Thank you.
Now you can.
I can? Okay, thank you so
Yes.
much. Are you able to see my screen? If you have not got your this image at hand, take a screenshot now. Okay. Now let us look at this component for a minute, and I want some participation on the chat box. Here's what I'm asking you to do. This is a component that's going to be machined. Okay, so you can imagine I have a raw stock I have to take. What should be the shape of the stock? Cylindrical, right? Thank you, Himanshu. Very nice. So that cylindrical can have a maximum of what dimensions to get started? This is, remember, this is a drawing of a finished part. 75 mm into 300. So that is the dimension of the finished part. So most likely you could go to the market and pick up something which is standard sizes that could probably be 75. And then you have a long solid bar and you cut them into slots of 300, right? Or you could take a slightly bigger dimension. For example, let's say 77 or 78. Yeah, and 310 on this side so that you have enough space to hold and do the job. So for the sake of this presentation, okay, I hope you've taken a screenshot of this. For those who don't have this drawing sent out to them, let us say we have in the market a ready stock which is about 77, and we are going to cut this length for 310, and we are going to build this geometry. Okay, now here's what we're going to do. We're going to open a DFM tool. Where is that? I have multiple screens here, so it's making me a little. Okay. So again, I'm showing you this demo, ladies and gentlemen, in a way that you just have an idea of a part to be made. Okay, you probably have a rough order sketch, and you're going to get started. Okay, machined shaft. IIT RPR 001. I just want to make 10 shafts. So what do you think is the envelope shape I should select for this geometry? Absolutely, solid cylinder. What could be the overall dimension I should give here? What is the diameter length here? No. So here's the answer. Hold on, guys. Whatever you give as envelope dimensions, please know this, that this is always of the finished part. This is not of your raw materials. I hope that's an important learning that you understand. You will always give the envelope dimension of your finished part, of your part, not of the raw material. So this is going to be a 300 mm length, and this is going to be a 75 mm, right? And since it is a solid cylinder, you could give a different average thickness. You could go as high as this. You could say the average thickness is 75. It doesn't make a difference unless you're selecting a hollow cylinder. Okay. Yes, always a finishing. Now let's go and select the process and material. Now we'll go to machining. This is a very good crowd. I like it. Everybody is participating well. So there, if you see in the machining, there are different opportunities. For the sake of this learning, we're going to take the full analysis. For others, if you want to learn, you're welcome. While you have the software with you, you can go to the on context, on the help menu. In the help menu, you'll find, in the help menu, you'll find online tutorials. If I click on online tutorials, ladies and gentlemen, you will find a lot of videos that are on our principal's website of the previous and this is the new version. You're free to go look at it, download it, and learn from this while you're having the software at your disposal. Okay. Please feel free and do some interesting stuff and share with us. We'll be happy to share it to the rest of the world of what you're capable of doing. So let me come back to this and take machining and take full analysis. And I'll just take for the sake of this presentation, maybe an aluminum alloy and say OK. So what you're getting now is, again, remember, when you select this first level selection, you get the primary process and all activity related to the primary process will be listed on the left hand side. I repeat, when you select your geometry, when you select the life volume and then go and select the process material icon, and then when you have a commodity combination, what comes out for you is this primary process. So depending on the process combination, you have this list on the left hand side, long or short, depending on what immediate activity is connected to that primary process. Making sense? Making sense? Say making sense or yes in the chat box. Okay, so now there are a few ways I wanted to see how this, especially from a machining perspective, this impacts. Yes, batch size usually is a divide by 8 or a divide by 10. That is a default setting, but we can go and change it. And that's the first one amongst the selections I would make and calculate. And the impact of the batch size directly hits on what we call a setup cost. What does it mean is you have a setup, and in that setup, you're making so many number of parts. That setup expense will get amortized, averaged over those many number of parts. Now, when it was 1, the cost was so much. When it was all 10 parts, it gets that cost gets divided over 10 parts. That's why you're seeing this kind of a number. So you can go and say, what do you think could be the raw stock material? You can have choices to make here. For a component like this, a round bar is preferable. So another thing is, since I'm working on this part and I have a drawing, I can load this file. This is something that we've not shown you previously. So here's what you can probably do. I can go to this part and pick up this shaft drawing and get it into my. So every time somebody who's reviewing my drawing knows where this. Oops. This picture is gone somewhere else. So I could look at it. So you can have records of such steps all through your different stages of your. So you can load files at different stages if you want. Yeah. Let me get back here. So the round bar is fine. This is the cost that is taken from the database. This is a material, scrap material cost. Now it's asking what is the way in which, imagine you have a long, if you're seeing my screen, you have a long stock. Now you have to cut it into segments of whatever lengths you want. So what method of cutting off you are employing will determine certain amount of cost here. So right now, to the abrasive material, if you're using a bandsaw and you calculate, this is going to be the impact on cost. If you're going to select some other method, it's going to be an impact on cost. It's more expensive than this one, right? So normally the defaults will be the most economical setup, but when you're actually doing a practical, you may not have this. So you go and closely select whatever you have as your practical setup and do this for. What method is this consideration and other? Guys, you have the tool at your disposal. Himanshu, please try that. I have 20 minutes to finish this demo, and if your time permits, we'll explore all of those details. So next thing that I want you to know is this part volume is estimated from the geometry, and as you keep machining the part, remember we are going to start machining the part, right? So as you start machining, you'll be removing material. As you keep removing material, that material removed gets automatically subtracted from this volume, and that will add up directly to the weight of the product. This is one way you could do this exercise. But let us say you have imported a CAD geometry, then you will see this in what color? if you've imported a CAD geometry, you'll see it in what color? Orange color. So if an orange color comes in, then the volume gets locked. Okay, that it is not the whatever machining steps you do doesn't get calculated from this tool. Just watch this number. You will see how as I go do this presentation, we will see the thing getting changed. So the next thing is about the workpiece. So right now it is saying the actual bar is about 3 meters long. This is a default database. Here is where we will tell our workpiece geometry. Remember, we said we should take a slightly longer part. You could here say our workpiece geometry is 310 mm in length and perhaps maybe 77 mm in diameter. Do all of us recollect this? Yeah. Now, so again, these things of the activity for actually doing the cutoff, this labor rates and all that are given here. But these are, as you see, I'm using the US database. But if I want to localize this, maybe it is less than $1 if I'm doing somewhere in, say, Chennai's industrial estate or something like that. Based on that, I can quantify the impact of doing this cutoff. Now, let me go and add a machine tool setup. What kind of a machine do you think will be sufficient to do a part like this? This is a cylindrical job. Most of the options are turned. So do you think we can select a simple generic lathe? Right. So I'll just select an automatic generic lathe. One more thing. I'm looking at all of you as DFMA future champions. Okay. Don't get very benevolent and select complicated products or machine tools to do your job. A good DFMA guy will select the most economical machine because your job is to be as stingy as you can with getting the best time and the lowest cost for the product that you want to build for your company. Get it? So if something can be done with a simple machine, select it. You don't have your handicap, the biggest machine you have or the smallest machine you have is something like this, fine. Otherwise, don't get too benevolent and select fancy machines. Yeah, nothing fancy. Don't select fancy. If you can do it on an economic machine, that should be your benchmark for costing. Okay, that's how we work. Fair enough. So that's the machine that we have selected. Sorry, it has selected twice, so let me delete it. And you know all this, right? Already, that which is you have the opportunity to change business rates and things and so on and so forth here. But something you may not want to change is like the basic process parameters of this machine, like for example, the spindle speed of the machine, the kilowatt hour of the motor that operates this machine, and so on and so forth. So since it is a lathe, I think I'm more comfortable having a lathe with a 3-jaw chuck because it's easy to lock and unlock the machine. So right now you see it's also asking, do you have any reversals? I am not selecting now. As I keep building the steps, if I think I need a reversal, at that point I'll come back and add the reversal information here. Let's go add a operation. I'm going to machining and I'm going to say turning. I can select multiple of these opportunities. For the sake of the speed of this exercise, I'm going to say rough and finish cylindrical turn. I'm going to select this as my first option. And what I want to do there is I'll refer to this drawing. So imagine that this part is actually 77 in diameter and is about 310 in length, right? So I have to bring the whole thing from 77 to what diameter? 75. So I want to do that through and through for about 300 mm length. Okay, let's go do that. I'll say the workpiece diameter DW is the outer diameter. This should be 77. I want to machine it to DM. You see the drawing here? That should be 75. Absolutely. And the length I want to machine it should be. Get it? I give this 3 inputs. I calculate. Boom. I get all of this information. Ladies and gentlemen, I want you to notice, and I think I've emphasized this previously. Many people think that is, oh, this is one big Excel sheet calculator. Well, there is more to it than this. Because if I show you the operations library, for turning operation, and if I edit the formula, that is the formula that's running in the background, ladies and gentlemen. Yeah, and this is the number of variables, about 77 variables running in the background. Okay, but is the customer or the user bothered with it? No, only those things that he needs to focus on his design is going to be here for his review. Okay, so what all comes out here apart from the cost is, I want you to notice that the actual machining cycle time for this operation is measured by the software. The amount of material removed is measured by the software, and if you go up, if you remember, this volume will keep on getting changed, rather reduced, as you keep on doing the machining steps. Okay, so I've done one step here. Let's go back. Now imagine that we've run it for 300. I want to probably machine this for 175 for this diameter of reducing the weight, reducing the diameter from 75 to a 50. So I'm going to do that step. Okay. Let me insert an operation of rough and finish cylindrical turn. Now I would start with 75 as the diameter. Just give me a second. 50 as this dimension for a length of 175, and of course these allowances are, you have choices to make, you can choose and make, but right now I'm leaving it at the default to quickly run through the steps. And as I said earlier, I would normally make this is stock. I would give names like this so that if somebody wants to reviews my design, they know what these steps mean. And sometimes if it's complicated, I would actually take snapshots and put as my own thumbnails here to make my explanation much more easy. So 2 more steps I think I will add. I hope you're getting the drift of it. So let's create this profile of a dent here, and let's create a drill on this side. So as I insert an operation of grooving a tool, which would, this perpendicular groove makes sense, right? So I will select that. Maybe I'll answer it a little later. I'll also do the drilling of this hole, add that, come back to it, and say the drilling this groove is about 10 mm. It has to go for a depth of about 5 mm. Okay, so the diameter of the work was 75. Guys, you're following me, right? Tool width is 10 and the depth is 5 mm. So that defines a groove, and the single drill hole is something that is on the right hand side. So it's about 16 mm diameter and about 50 mm length. So I'll say diameter is 16, depth is 50, and it is finished. So I have done all of these features. What I have to do now is maybe face off or cut the part. I'll probably insert an operation to cut off the part. Okay, normally this is not exactly right, but you need to understand you definitely have to do this step finally. So I'll cut off the part from an outer diameter of 75 to a 0, correct, and calculate. And all of this sort of closely defines my there's nothing like why not, right? You see, when you think of why not this, why not that, just gentlemen, just know this, that there is no one way of doing things, one way of fabricating this part. So you have a challenge with how your colleague or somebody else is doing, take it up, paste it, rename it Himanshu's doubts and do whatever you want to do. Rechange, reorder, create a reversal, and see the impact right there. Get it? So that's that. That is this. You see, this is the impact of the original Himanshu process, right? I just added a reversal there. That's why it's adding that cost. Okay. So how does it play out? How does it play out on cost? You can see all of these details. So even finding finer details like this makes sense. Now, one more thing is don't get stuck up too much if you're a part of decision making, because you see there's almost 70-80 paisa difference, which is substantial. Another thing you should know is right now I kept the setting at 4 decimal places. If I set this to 2 decimal places, the things will be hard. It's not so significant, right? So make sure when you're doing reviews, you are keeping your decimal places to the right thing, depending on the volume that you are making. Because you're doing 1 part, 10 parts, 4th decimal place, 3rd decimal place doesn't have so much of relevance or significance. So I hope you have a copy of a exercise that is to do the machining. If you have any questions around this, we will take it up now, or we'll go on to the next topic, because we have lots to cover for today. And we also want to give you a discuss about a exercise that we would like you to take up. Okay, let me make sure that we are took in the starting, right? What we are supposed to do is so this is your workpiece geometry that you started with. So what happens is this value of this geometry is estimated in your material cost. Also, I want you to know that in the stock process, you see an important aspect is there's a cost of material and there's a cost of scrap value of a material. Now I have a question for you. If I make the scrap value 0, okay, please note the question. If I make the scrap value 0, what do you think is going to happen to the material cost of in my component? Is it going to go high or low? Right? So what it means is you are having a raw material cost that you are incurring when you buy the material, and then when you are machining the wasted material, you are able to sell off at a price. If you're able to sell off at a price, that is subtracted from the overall cost of the material. So if I have a good recovery rate for the material, I'm just putting arbitrary number as 1 and using for calculation, then that cost is recovered. If you're not recovering, then you will probably be spending and paying even for the scrap that you're generating as a part of your process. So just to know that, because depending on expensive materials, this recovery rate must be maybe a higher percentage, right? So right now it is something which I gave, so I'll unlock and leave it at that. And of those of you who recollect, you see the volume of the part as I kept on adding operation steps from about 1,300 something centimeter cubed has reduced to 900. This will happen when you are doing a stock process and you keep adding steps. The volume will keep on getting subtracted from this original part geometry that we had, original part geometry that we took to arrive at the final geometry based on these operational steps. Okay. Wonderful. So the next thing that I had to show today was, hey, where's that? Just give me a second. I have too many. So I already told you about these online tutorials. Please feel free to go here. If you don't know how to, you can also go to this link, the DFMA support, dfma.com/support. You also find a link on our dspat.com. Maybe Balaji or Yogesh, I request you to get that link of the videos and share it on the chat box. Maybe that'd be a good way to. So if you're able to see my screen, I wanted to show these activities today. Now, yesterday we built a part. Today we've done the component in DFM. I can actually show you how I can build these, bring these parts into DFA. So where the cost that you analyze for can be imported directly into the DFA tool. So just give me a second. I'm trying to open my. I have two screens here, so. Too many things. So I'm opening up the DFA screen of. Let me take up the old part that we did. So if you recollect this DFA exercise we did, no, you're going to get the assignment now, Rana. Hang on. What's the hurry? Going somewhere? You're with us till 11 o'clock, right? Super. So hang on. The assignment is coming. It's a simple assignment, but it's in depth. If you can do it right, there's lots we can learn from that simple exercise. I'll be sharing with you. So if you remember this end plate, this component, right now I got it as a part, correct? Now you also remember yesterday in the DFM, I had done analysis of this component as a sheet metal part, if you recollect. Right, we did this with this part yesterday as a sheet metal part. Now I can go and so imagine the DFA idea was done by some set of engineers sitting somewhere else in the globe, and they're accessing a server, and the actual part level costing for the components was done somewhere else. So through concurrent engineering, quick demo is what I want to show you here. I can go to the end plate, I can right click and I'll say, hey, connect this to a DFM analysis of something by linking it to an existing file. I can link up and about where I put this up there. Just give me a second. DFA case studies. We did this yesterday. Okay. Now I'm going to bring up that file. I'm saying now what I'm trying to show you is in the DFA level, this was an idea of a part. This was image of a part. In the DFM, we've actually taken the part, we've done a 3D model and engineered it. And now when I open this up file, it is saying, hey, in this DFM file, you have 4 different analysis done. Which of them do you want to link to? I want to link to the lastmost file because this is the most precisely estimated file. I can click this and look at a few things that are going to happen. Look at this image. Right now it is that of a part, right? When I click this and look at this manufacturing data in the DFA file, 2 things I want to show you. The image of the existing part before I link it is showing the image of this part icon, and the manufacturing data, it is something which I can edit. That's how these menus are right now. But when I link it to a DFM file and I say OK, you see the image changes to a symbol like this. It means it is a thoroughly analyzed DFM file that you've got here, and the manufacturing data is locked in. You cannot edit it. Why? Because this is being driven from this file. So imagine I have different parts, different vendors or different teams working simultaneously. As each of them are doing work, you will get these parts into this. So when you're going to do your group exercises, which I'm sure you'll be given opportunities to do, Repeat. Okay, Shashank is asking me to repeat. Can somebody? Oh, you can't repeat. You can't voice out. Can somebody do something on the chat box to backtrack what I just said? Okay, one more time. Let me take another part. What I'm trying to show you here is, if I have an idea of a part, and let me take the cover for that matter. Let me take a cover for this matter. Okay, I've taken an entire different part. I have a part. I have done an analysis of this idea of at DFM level for this component. Yeah, let me take this image. You can imagine this sample, right? Now at this level, I only have idea of these parts, that I want to have a base part. It should have a motor, a sensor held by sensor screw, and I have an idea for cover. This is one activity I've done in the DFA. Simultaneously, let us say my other team members have also done a thorough analysis of the component. Let me take another component, for example. Let me take the cover, which we did on the day one, cover IITR. Okay. So remember, we did different kind of covers. We did casting. We did casting in with the Greaves database. We did it in sheet metal. We also did it in plastic. Okay. For the same geometry called cover, we have a DFM file that has been analyzed. What I'm trying to show you here is, I have this component and I have an overall estimate which I have keyed in. But now I also want to have done a thorough part level costing of this component. And I want to link them, because DFA and DFM are actually true concurrent engineering tools. They can work simultaneously, transferring data from one to another, thereby helping you to get rapid feedback of your design intent, giving rapid quantification of your design idea, and thoroughly getting part level cost, and also getting assembly level estimate for time and cost of putting your assembly together. What I'm showing you as an example is, I'm able to link this file. How I do that? I click on that, on the component, I right click and I say DFM analysis. I have two opportunities. I can create an entirely new analysis, but since day before yesterday we already done the DFM analysis of this component, I'm linking to a file. When I ask linking to the file, it's saying which of the files you want to link to. So I will say link it to the cover file. When I bring up the cover file, it says, hey, this cover file has 4 different analyses. Which do you want to link this component to? I want to link it to the most, let's say I want to do to the plastic, and say, okay, the data of the plastic component, the tooling cost of the plastic component from the DFM file, the plastic which we did. You see this value 38,000, 14, 6.9, all this will automatically come into the software. Making sense? You are welcome. Now your job is to do something like this interestingly and come back to us and say, hey, we've done something of value. Okay. So that was the third part that we did. I think we're good on time. That's nice. Now, I also want to show you something related to this bill of materials. Let me close this. I don't want to save it. And this is another sample that I want to show you. Sometimes in your CAD software, you'll probably be making your, yeah, I'm making, there's nothing like true design. It's something like saying perfect product. It's one design. Okay. And you've already done a CAD model in which you have created the bill of materials. Again, I want to show you here is you can add a CAD model from your software into the DFA file, and where is the data? I don't remember where I kept it. Just a second. So I can import a CAD geometry like this. In the DFA, what will come through is the overall XYZ dimensions of the envelope shape. So my setting, sorry, is in My units are in inches. So let me change this to metric. It makes my life a little easier. Okay. I can also import what I said is I can import a bill of materials. So when I say import bill of materials, you have this data example in your exercise in your files also. This has been loaded for you. So I'm taking any of these two options that are there. One is I can have a text file, or I can also import comma separated values, or CSV files as we call it, CSV comma separated values. Let me open this bill of materials for the motor. Imagine if this motor file was already made. If you want, you can do this alongside with me. If you have the software and you can simultaneously do this, otherwise don't bother. We can send this out. So usually, if you look at it, there'll be a lot of things that the CAD software guy would have done as a part of the. So normally, let me untick this. See, the data will be jumbled like this. Yeah, comma separated value. So if you select on different definitions, you'll see how the data regroups itself. One of them will work for you well, depending on how the format is imported. Just be patient enough to do this one time so that you figure out what is the delimiter that is working from your exported file to what you should get it here. Okay, so this is a one-time exercise that you may want to carry on. Second thing is, where do I start importing from? See, this is the name of the file. This is the name. I don't want to import this. I want to import from row number 2 because this is where the actual data is. So I'll say start importing from this data too. And when I click on next, now it is saying, can you please map your CAD data based CSV file to what you want to get into the DFA file. So I will say the first one is level. So this is level. It is still not imported. I look for the field. All the fields that are possible in DFA are shown on the right hand side. Your job is you go and match them to your imported file so that it becomes appropriately matched. So this column number 1 is level. Column number 2 is name. So I click on this 2 and I'll go to field and say you map it to name. Column number 3 is total count. I click on it. For us, total count means repeat count is a word we use as a terminology. So we'll say repeat count. Now column number 4 is part number. So I'll say part number. Column number 5 is piece part. I will say piece part cost per item, so on and so forth. I have not created these lists, but so you can go and add this kind of information. And when you say next, and if you're going to regularly use the same format, you can give it a name, IIT Rupar format, something like that. And I say finish. What will happen is you will get the quantity, the part number, the like I've added the supplier name to the notes. So all of that will automatically come here. Okay, but definitely what you have to do as a user is this is only creating one kind of connect from the outside world, which is CAD or ERP solution or PLM into DFA. But once it is here, it is our job to answer these questions so that we get the assessment right. Making sense? So that's the other thing that I wanted to show to you. And please note that there are different types of reports that you can generate from the tool. And there's also ways in which you can customize the reports, and there's also ways in which you can export out the reports. Let me just quickly show you a few things. Right, so I can generate different types of reports here, one after another, and I can change the currency in the reporting. So wherever there's a dollar value, it will change to a rupee value or whatever is the conversion that you're giving, because the dollar or the value for cost is a part of the large calculation. I hope you understand. I've shown you 2-3 examples of the algorithms and the calculations that are running in the background. So there, the cost is defined by that value or by that symbol, dollar. Whatever you want to change it, you're free to do it, but also make sure that the other things are also appropriately right. For example, is the labor rate appropriate to my setup and where I'm doing the project or where I'm making my component? That also has to be corrected. That will make your prediction suitable for the location or for the enterprise from where you're doing this, for whom you're doing this costing. And also you can export out these documents in several different formats. So depending on who you're sharing with somebody who you don't want to edit, blah blah blah. So that's how you will probably do it. And so that's my exported out file. Here's my so you can create an export out file. You have opportunities for changing logo and all of that stuff, which I think you guys could be good at exploring. And help you to you can go and change your logo by clicking on that icon here, and you can create several different opportunities for doing this. There's some customization you can do on the report options as to how you want the margins, blah blah blah. Because at the end of the day, you may be wanting to share your data out to the outside world, like your vendor or your project report or whatever the case may be. Okay, so far so good. We have 2 or more titles that we want to cover. So I'm going to take a few minutes to show some case studies from a few backgrounds, and then I want you to keep some prepared questions that you may have towards the end of the session, because these 2 things we're going to announce. Balaji, Yogesh, have they already got the exit questionnaire sent out to Dr. Dheeraj, and is it ready to share when we ask them to do it?
Yes, sir. I will call Dheeraj, sir, and I will.
Please do that. Okay. So I'm going to continue from my case studies here yesterday to create some more interest on this. I'm not sure if I got to show you this yesterday. This is a case study we did for UAV project, wherein this was original design was 52 sheet metal parts, and then with the design team and the director of the institution, we kept on exploring why not we make it as a singular part. Now the excellence criteria for this case study was that because it has many sheet metal parts, these little blue dots that you see are actually mounting fastening parts for the electronic subsystems that were mounted on it. Because of this being in so many sheet metal parts and this being a UAV, at different angles of climb or operation of the aircraft, it was getting into high resonance. So from the final efforts of about 3-4 months of work was we changed from a 52-part sheet metal design to a 2-part die-cast component. And the total number of components of this whole assembly from 816 parts became 102. I have the sample here of this component. Let me open it up for you. So I don't have all of the sheet metal parts analysis, but this is the one finally that was selected for that we could get if you make it as a singular part. Now this kind of design is sort of disruptive to make somebody think through from a 52-part different assembly to making a singular part, whether as a cast component or as a injection molded component or a machining from a raw block, like an example I showed earlier, like this. But these kind of things bring about high value when you actually explore it thoroughly. Sometimes it could be very positive that you are able to bring about good amount of savings. Sometimes it will also help companies that when they have this notion that, hey, maybe this is a better idea to do it as a singular part, it has proven that it is not a good idea to make it as a singular part. Thereby, it gives them the confidence to go back to their old ways or make it a simpler, multifunctional parts. So the rule of good design is that you should have a good part count reduction in your product, but that rule does not hold good for all situations. So what applies to one type of a design need not necessarily apply to another. Please be aware of that. So even if you're facing experts, people have intense experience when you go into organizations, they will challenge you saying, I know this from so many years of my experience that this happens. Please take a moment to use a tool like this to validate whether that is true or not. Many times you'll see, you might find contradicting results. Okay. There is no modus operandi. No, as I said, we always talk about, actually I didn't show it today. We always talk about there is always a better way of doing things. That's what all this means. If you remember the exercise which I showed yesterday, right? Sometimes we do many industry, engineering, and academic projects. Like this example here. This is our academic customer who does a lot of industry projects. I hope you are able to see my screen. Let me run it full from this current slide. Now, this is our customer, a client, and he brought his competitor's product and he said, hey, my competitor is selling more number of components of the sub-assembly compared to me, and I'm losing out my competition and I'm losing out the price war. I'm not able to meet his price targets. If you can imagine, this is a old case study. This is that switching mechanism that comes behind the steering wheel of a car. Do you see what is the difference here? Can you identify what is the problem? What do you see? I've kept it in full-blown markup for you. What about the connectors? Simple. An engineer should call a spade a spade. You see two connectors in one case, you see one connector in another case. Right? Two connectors adding up to the cost. So when you ask the client, hey, when you keep this on the table, I can see that you are already outbeaten on cost. You have two parts compared to the fellow who has a single part. He explained to us saying, sir, actually, only this was the set of connectors. Then our customer added a few more switching features. So we just put in some more bunch of 6 wires and added another connector to the existing design. We said, you know what, if you do a cost analysis of this, the time for assembly, the wire harness cost, even the length of the extra wire, the cost of this additional connector is the difference why your competitor is able to make more money compared to you. So sometimes, many times you will see we engineers, we only satisfy a function. What we have to do is also fit and form related to your product so that you can make it a little more competitive. Okay, let me run you through the other case studies, which is more from academic and not. This is a case study which I really like showing many times. Is this is a jump seat of cars made by a company called Magna Interior Systems. The original design having about 160, 170 parts. Ideally, they were able to get a design to a 19-part design. But remember, all the time you cannot actually manufacture an ideal design. But in real deployment situation, they were able to get a 35% part count reduction, and importantly, a 93% in assembly time. What it means is this is a product made in the US. What used to cost them $100 today is done in $7. You see the difference? So that is the strength of deploying and identifying improvement opportunities with a methodical manner using the DFA and the DFM tool. Since the agri event, I thought I'll just put some of these images from some heavy equipment like JCB, where a 47-part design for a backhoe excavator was redesigned to a singular. We have many case studies from customers like John Deere and other farm equipment manufacturers, where they have brought about good amount of savings in their product. This is a tape cartridge elevator used in an office printer. This has got 95 plus parts and so many fasteners. All these little dots you see are fasteners. Redesigned to 36 parts and one single screw. I used to work with some customers in Malaysia. Malaysia has a national motorcycle manufacturer called Morenas. They work with Kawasaki. So I used to The R&D manager, the head of the R&D team, used to say, I'm talking way back in 2005, 6. He used to, my dream is to make a motorcycle without a single fastener. Can you imagine doing something like that? I mean, of course, today many of the parts of the motorcycle are not there. Like, for example, the carburetor is now replaced with the MPFI, right? So nothing is impossible. Just to find different ways of doing things. Some case studies from academic, maybe for academic interest. This is a cellophane tape dispenser redesigned to a singular mold component. This is a case study of a single part stapler done by a professor from German university. And this is done by our folks from a Bangalore university, where they've taken a 16-20 part metal punch design and redesigned it to a single part paper punch. They also gave it a name called Design for No Assembly. Okay, complete with the mold, the insert for these metal parts, and so on and so forth. This is an academic project done by students. Somebody I told earlier about the aerospace part. This is this very challenging single wing aircraft called a maple seed monocopter. This is the student's project that was done in, and this is a Katia rendering when his project was purchased by a toy manufacturer who wanted to make this as a toy. This is the baseline original design, and review for making the toy was this. You can actually look at this resources if you're interested to look at the. We have done some good case studies related to the level that with students we actually published it in international journals. This is a case study of an equipment like a burring tool. I can quickly show you this tool analysis. So this tool was given by a company that makes about 5 or 6 burring tools per annum, and every time they get a new design for the sheet metal burring tool, they go about doing the same thing. So which is designing by habit. When you have the same kind of a process, they just design by habit. So if you see the original design, 374 parts, just have a note of this. It has got two main systems called the lower and the upper assembly. I'm just trying to open up the CAD file for you. I'll also show you the image of this file. Here, this is the CAD file of this subassembly of parts of the lower assembly. It's a really huge file actually. And the reason I'm showing you this is to inspire you guys to take up something which really makes meaning, something where you think you and your group of team members can contribute to have a really good outcome of the project that you undertake and so on. So this is the upper assembly CAD views. Let me minimize this. Let me open up the image. This is the image of the file of that part. So this was a big part that we actually modified for the customer, which brought about a change. Anyway, the long story short is, as you can see, if I break up this, there are several subsystems inside it. So if this answers another question that you may have in your mind, which is how big an assembly can I analyze? There's no limit to the number of parts that you can analyze in the DFA DFM tool. That's what this is being shown to you for. So this was the original design, and after a few months of work, okay, from a 375 part design, we came out with a redesign, and then the redesign was further done to a 215 part component. 374 to 215. Nice. And of course, we got it published for the sake of the lecturer who undertook this project and the industry, and that is okay. So I wish you all the best in doing your own projects. I hope we can find some articles published like this. If it's too good, we'll request your university to send the files to us as a white paper. We will recommend it to the DFMA forum to see if they can include it in the DFMA International Forum next year. Of course, it is their selection criteria, but we'll be happy to do that for you. Hello? Okay. Am I audible? Okay. Great.
Yes, sir, you are.
My chat box was stuck somewhere, so I'm not seeing a yes or no. So this is one aspect I would like to talk about casting and about case studies. Then there are one thing that which many people do is they look at opportunities from other industry that they can incorporate into your own to see if it makes sense. For example, this is a totalizer wheel. Okay, a totalizer wheel is, on your dashboard in your car or motorcycle, you have this odometer that goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the next digit turns 1. It used to be a 23-part sheet, a metal set of mechanical components. If you take advantage of new generation materials, especially plastics, like this is a DuPont Delrin component, redesigned from a 23-part design to a single component, all including the spring, the gear, this is the spring component, the counter, all included in one design. Now this is disruptive, okay? From a 21-part design to a 9-part component. So these are very simple examples I'm going to give you for you to just think about. Like we spoke about the mobile phone example yesterday, how they used to have screws, how it became a snap fit. Today, mobile phones don't have the battery that you can access. You cannot open your mobile phone at all, right? I can give you much more earlier, simpler examples. Look at this 15 amps socket, the ones that you use for your geyser, AC, and so on and so forth. It used to be 18 parts or 10 families of components like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, the customer, the manufacturer is thinking, hey, how many times is our user going to be repairing wires and rechanging the pins? Why are you spending so much of time in putting this assembly together? Why make it a several parts? So he spends a little more upfront in doing an insert molded component, and he gets it as a singular part. Today, when you lose your mobile phone charger, or what do? Do you go about repairing it? That's a user experience. Just throw it, go get another one, right? So that user experience of how they use the product defines where it is to what it could probably become. So these are other opportunities. I mean, the exaggeration of this is the mobile phone. Buy another one, yeah. So that buy another one approach will happen how you structure the product. That's something customers would do. Let me show you another example of taking advantage of high technology and using it for the advantage of building a more preferred product for yourself. Remember, this is a table fan or a wall mount fan. It used to have sheet metal parts like this 1, 2, 3 sheet metal parts for the wings. It would have these two sets of rivets for holding the fan on the casting flange. And this casting flange would be mounted on a shaft with the screw that will slot itself. This used to be 12 parts. Right now, somebody like me or you would impress the fan manufacturer and say, hey, let us spend a few lakhs of rupees in investing on a singular mold. We can make all of this as a single one-piece fan blade. Secondly, what was about so many parts can be made in a few grams, because of which what happens is, this old fan used to be driven by a 250 watts or a 300 watts motor. Okay, for the same wind flow that you want, you can run this plastic fan with, I would say, 40 or 50 watts motor. So you're seeing the difference. Heavy parts, a bigger motor, investment into a new mold, singular part, 50 watts. Now what have you done? You've invested on high tech, you spend more money, but what are you going to do is, as a company, you will say, hey, our product is 5-star rating compared to that product, which is 1-star rating. Though you're spending less on building your product, you make the customer see value. You're going to tell the customer, hey, you used to have 250 watts motor, and in 1 year, if you operate that fan, you spend so much. Our fan is just a 50 watts motor. You're saving 80% of fuel or electricity bill rather, and that is why what used to be a say 1,000 rupees table fan, we selling it at 2,500 because you're saving money. It's called perception of value. You see the customer to perceive value. There is the example we showed yesterday of the rear wheel or the wheels of a motorcycle. Spokes wheel design to magnesium alloy wheel. Spokes wheel design, more assembly steps. Magnesium alloy wheel, lesser cost for manufacturer, but customer sees more value. He sees style, he sees lifestyle, or he sees whatever as an aspiration, and that aspiration you use to sell your product at a higher cost because you've invested more time or money on a higher technology. Making sense? Hello. Okay, so these are very simple examples, but you can look at different opportunities. 16 to 18 part sheet metal design done to just 2 parts. I think you know what this is, right? I know in lockdown many people don't go cycling, but this is a part of the cycle pedal, right? So, gentlemen, now you're of course you're all academic students. You're going to get some project opportunities. But if you're part of an industry or you're going to do an industry project, they may ask, when should I do DFMA? Well, it is never too early, never too late. And if you must have your whoever is your guide or manager to help you to do this review. So who does what is if you're I mean your manager or your project leader should facilitate the team to do group work. They should give them the time to carry out this group work, and they should give tools like DFMA at their disposal to carry out activities. And what should the group members do is take every suggestion as a part of the inputs. You know, many a time when we work on big enterprises, one fellow will be sitting there, he'll be the Paramatma of manufacturing knowledge in that company. When we make a suggestion, oh no, in my 20 years experience, I know that's never happens. So this form factor, you can never shape it in this way. I don't do that. I always play the role of the most silliest person in the room. Every idea I would put it because I have a tool that can give me an unbiased feedback of my design intent. So please, when you group in, take in every consideration and use the tool to give you a feedback of your design intent. Also know that where all you can deploy DFMA, you can take up an entirely brand new conceptual product, or you can take a current design. If you notice our 3 days of examples that we have taken, you take an example of an existing design and analyzed it in the interest of our learning. What you do there is you identify a problem area you want to improve. Like in our case, we looked at the cover and the end plate as a protection component and found out a way to make it a simpler part. Then find out different ways to redesign. Okay, explore the possibilities of making. Like if you can remember the cover, what if I make in casting? What if I make in casting in China? What if I make in sheet metal? What if I make in plastic? Options. Then whichever makes sense from a business perspective, use it to report. Now, which are the areas DFMA is used across the globe today, gentlemen? Developing new products, re-engineering, like I said earlier, benchmarking or trade-off with the competitor. How come he's selling more or less than what I am doing? Actually getting good estimate of their predictions, getting time estimation, and making several trade-off decisions. You already got the questionnaire. In the next 50, actually, I should have requested you to be submitted now, and then giving you a 10 minutes time. But since you already got it, the time on my clock is 10:15, then 10:32. Sorry, can we get it by 10:45? No, there's no. Please give us time. Why should I give you time? It's just 8 questions. Fill in your name, fill in your email address, keep answering. Actually, we're supposed to start it a little later, but let's do this till 10:45. Please don't consult your friends. Just answer it and submit it. You can submit it later than 10:45 also. All right, but we will. But I think it's not fair to you, because we were supposed to give it at a certain time and ask you to stop at a certain time. I didn't notice in the chat that has already been given to you. So shall we give a few minutes for you to finish it? This is like 10:32 on my clock. And if you are seeing that link that has been shared to you with the exit questionnaire, can you please fill it up? Because I have something else that I have to talk about as a part of today's presentation, which is doing an exercise. Okay, so I'm going to give you 10 minutes starting now to finish it. Balaji, can you please follow the Google feedback form?
Okay.
And those forms that are being posted, say 10:30, 10:45, we sort of not 10:45. It's too much. Actually, it should be 10:40 because they've already got the screen. Yeah, the link is resent now. 10:33 now. 10:43 we stop. You can continue to submit beyond 10:43, but we will have a timestamp on it. So do it ASAP while we wait for you to finish it. This was supposed to be our flow actually. Exit question towards the last. Balaji, Yogesh, have you already sent the PDF also to the team?
Yes, sir. Shadows. They are uploaded in that agreement link.
Oh, that is there, is it?
Yes, sir. Both of them uploaded.
Great. We shouldn't be calling it group exercise. We should be calling it singular exercise, Balaji. Let's see how it works.
Yeah. Hello, Mr. Sayed. Good morning. Yeah.
Yes, good morning, Dr. Dheeraj.
Yeah, so I have shared the link with these guys. So they have to go into the assignment sheets that I have shared with them generally, and the links for the questionnaire and the exercise problem is there.
Yeah, about the exercise, I will describe to them what I want to do. So since we have already shared the PDF is great. Once the exit questionnaire part is finished in the next 3-4 minutes, I'll talk about this and then leave the forum open for Q&A and we will end the session today, sir. Hello?
Yes. I think they are getting it. They're getting it.
Okay.
So actually, I'm opening this feedback to other viewers also who are watching on YouTube. So you will be continuously getting responses. So some kids are doing on their own, like.
Okay, absolutely.
Mm.
If I go to YouTube, is there a link that I follow, or is there something I can use as a search for getting this?
Yes, you can subscribe to our channel, AWaDH IIT Ropar. Like this is how we advertise it. So you will see your live session appearing there. So you can search AWaDH IIT Ropar.
I've done IIT Ropar and
AWaDH, yeah, AWaDH.
oh, that one.
Yeah.
Okay.
So few students are doing there, but they will be doing later on also, because the students who are with us here on WebEx and on YouTube, or those who applied for the internship, we are offering them certificate if they solve all the questions and assignments within the deadlines and all.
Okay. Just in the interest, Dr. Dheeraj, any
Yeah.
indication that you get on the statistics of your YouTube right now? Because here I know how many people are seeing.
Come again. What do you need?
Do you know what's the statistics of your YouTube viewership since yesterday?
I have to check.
Okay.
Yeah.
Because some of the friends that I know have seen on the YouTube link, because I know they were not on the session. They said, "How did you see?" They said, "I was following the YouTube." They were saying.
Okay. Let me see.
Actually, sir, I have pinned the YouTube link for live session in chat box. So
Okay.
they can get it.
Yeah, I'm seeing it. I'm seeing it here. I'm seeing my own voice repeating on the YouTube link in my other laptop. Great. So another 4 or 5 minutes more, guys. If you're done, you can give me a shout that you're done with the exit questionnaire, so that we have a little more time till 11. Great. Thank you, Ashirban. Yes, you have to submit the Google form now, Kunal. The ones that have the questions. Spreadsheet. Yogesh Balaji, can you cut paste the link here in the chat box? Some people are asking for the link to the exit questionnaire.
It is there in the sheet. The questionnaire as well as the exercise link is already in the sheet. Students, please go there to the Excel sheet or the Google sheet. Within that, the DFMA questionnaire and the exercise sheet link is enabled. Please click there. Thank you, Himanshu.
So how many of us have done? Can you probably say done message on the chat box? Okay.
Ronak, you can wait a bit. Guys who have done the assignment and exercise and questionnaire, you can close the link, I think.
Yeah, that'll be good.
I'm really impressed with the online mode. I think things are working very fine. Like people don't need to travel even. I think it's a good way.
Correct, Dheeraj. I mean, over the last 1 year, we have between my team and ours, we have curated the content so that it makes it look easy to do. I think it's a really hard subject to even do a one-on-one. But through COVID, we have learned to adapt ourselves, how to get the thing and get people started. Just to let you know, 6-hour content curation, you're the IIT Rupa is the first that we have done. So
Wow.
actually, yeah. So I mean, this is 40 years of work, so it is definitely not enough to put it in about 4 or 5 hours or so. But it gets you started, and I'm sure the student community will be able to maximize their learnings with the other support that we have got, like the video links and the PDFs that we have built and updated.
Yeah. So I truly feel that students, when if they do the exercises and all in this 1 week, they are going to gain a lot of things because the tools are not readily available for everyone. Like the tools that you have made them available, they will really understand the process of manufacturing, assembly, what cost optimization they have to do. It's a wonderful opportunity for them. Yeah.
So Ashirvad Sahu, we are not going to do a group exercise. We are going to, this is what is supposed to be a group exercise. We are going to dismantle it to a singular exercise. That is what Dr. Dheeraj has told us to do. But we'll talk about that in a minute. Just 2 more minutes. And after that, I want to get started with what I want you all to do as a part of the exercise. Preferably, as Dr. Dheeraj says, we want you to do it individually. But I can also tell you how you could probably do as a group. And if you're doing it as a group, what you should do, or let us know so that we know that why so many group members have a similar results. Okay, I will tell that in a minute. Yes, Dr. Dheeraj.
No, I'm fine. I think let them do it individually because they have to submit the solution and all individually for their evaluation. But they can have a discussion with the group. They have already found some Discord group or something. So they are talking a lot there rather than here.
Okay, great. So I'll tell you how that should be done, because DFMA is a tool that should be done where we say 2 heads are better than 1. So I'll talk about that in a minute. Whatever works for you guys should be is okay. The objective is just to see the learning and putting it into practice. That's all. This is preliminary. I understand there'll be challenges of learning and actually applying, but with practice, you'll probably become much more better. So guys, I'm going to give you another minute before I call it a time, and I request Yogesh and Balaji to mark the timeline as you're getting the feedback into the Google form. And okay, please send the link. Which link are you talking about, Kumar? Okay, guys, we're close to the session now. I please request you to look at my my screen. Do I have everybody's attention on the screen? Hello. Great. So, gentlemen, now what I want you to do as a part of your utilization of the DFMA software that you have access to is to analyze a regular one everyday assembly called the pen. Okay, because whatever you can learn from here, if you deploy and put it into a part of your analysis, you can imagine what all you could do if you were given a unknown product for you to analyze. As I said, DFMA is a systematic procedure to analyze and quantify. 77 responses on time. Congratulations to those. Don't worry, it is just a matter of saying, hey, is my voice cracking? Is it? Hello? Guys, can you give me a shout out whether I'm audible or is there an issue with my... Okay, Mridula, you need to check your system perhaps. Guys, so what I want you to do is look at this product. Okay, get one product like this, which has a disassembly that looks like this. And for the interest of this group, my team has also marked the names of the components. So use the similar name when you build your DFA product structure. I want you to do a DFA analysis, dismantle this part, reassemble from the first, assuming which should be your base part, which should be the second component, which should be the third, to build your product sequence. Okay, and prepare a DFA analysis around this. Now you may say, hey, such a simple product. My thing is, if you can do a very decent DFA analysis of a product like this, which you hold in and day out all through your life, at least you've seen it and utilize it. There's a lot of learning that we can capture from this that you could probably use in other products that may be probably thrown at you, which may be new to you, and an approach of how to solve such problem that come your way from an assembly perspective probably can be laid out when you do an analysis like this. So a few tips around this. Do you want to know some tips? While I agree with Dr. Dheeraj that because of the disconnect, you have to do this individually. You can probably do this if you form maybe groups of not 3 or not more than 4 amongst yourself, okay, and discuss how this product should be sort of assembled on a shop floor of a company that manufactures pens. I bring your attention to 2-3 important aspects. Even consider that if you're a part of a pen company that manufactures a pen of this nature, okay, a cello pen that's about 10 rupees or 7 rupees, how much should be the life volume? What should be the thing? So all this could be scenarios, these what if scenarios. Please put it into the part of your analysis. Yeah, coming to it, Ashirvad, we don't have to re-engineer the product first. What I want you to do is get the list of these items in your DFA sheet, in your DFA software window, from word go to the last part. Also, make your own assumptions. I know that you don't have access to this information, but make your own assumption of what should be the part cost of this one, what should be the part cost for this, so on and so forth, and build it in your DFA. After you have done that, please also make your new proposals, like we have shown. Make a copy, make a new proposal of how you could probably simplify this product, and also build that and send it to us. We don't want to see more than 2 iterations of re-engineering or redesign, and that should be good for the whole exercise to be done. While I go with what Dr. Dheeraj says, it should be done individually and submitted. I am taking the liberty of asking Dr. Dheeraj to give you permission to work in groups. The group should be identified. For example, if you have, say, Discord group number 1, it should show, okay, Shweta, Harish, Yogesh, and Syed is a part of that team. you have to do your own individual results, but you can brainstorm about what you think are the iterations. Is that a good deal? So you get more help in doing your group exercise. Yes or no? Dr. Dheeraj, do they have that permission? Yeah, the group exercise will be fine. Doesn't mean that the two people do the work and the remaining two copy. Okay, there are ways in which you can ascertain it. So anyway, you have to submit your own DFA exam case or file with your name for the valuation or whatever that Dr. Dheeraj would want. So make sure you get it right. Okay. What's the deadline? Well, if I were to do this as an exercise, I would normally give about an hour and a half to 2 hours. But I understand that you have classes through the day. So shall we say by tomorrow evening? Is that a good one? Or do you all don't have time at all, even in the evenings, to collaborate? No, I know that, Ashirwad, that if you do it individually in a group, you can do it better. Where do we have to submit? Saturday, Aishwarya, you seem to have a lot of time at your hand, man. I'll leave it to Dr. Dheeraj to make that decision and announce here. Dr. Dheeraj, if you're online, do you want to? Saturday is a given date. Fair enough. Saturday then. That will be too long for a part like this, but yeah, you could take the liberty to do that. So we've come to the end of the session, and I'll leave this open for Q&A, ladies and gentlemen. If you have some questions, I will be very glad to answer. So what you're going to do here is you're actually doing a tear down of your component. If you're seeing my screen. And are you able to see my screen? Yeah. So you're going to do a tear down, and those which are unfamiliar, you're going to ponder around it. And when you're pondering, if you have some doubts, what you also do is, let me make a new analysis. You will leave notes at the different stages of your parts. Yeah, you will say, oh, I didn't understand this, or I made this assumption. You will leave notes here. If you have some ideas, you can even take a sketch of it. You can do a sketch on a piece of paper, or a 3D model, or a 2D drawing, or on Paint, and also load those images here in your files. So the more detailed your thoughts are, please lay it out by using these tools that are there to explain your idea or the re-engineering idea or your doubts through the DFA. You don't have to give a separate document.
Yeah, Mr. Syed, I'm back. Sorry, I had to cut a call for some urgent calls.
So what I was telling them, Dheeraj sir, is normally we'd give a couple of hours in that exercise session only.
Sure.
But I think you marked this as a Saturday for the day of submission. Is that valid for this exercise? Okay.
Yes. Actually, they have multiple assignments to do, so they are loaded with a lot of assignments. So
Okay.
I think it's good to give them time, because anyway the software accessibility is with them. So let them take time to do it.
Please. And if you have the opportunity and the time and the energy, and you have something at your project for the students, they can use this tool to validate that also and throw that up. It will be nice to see if you've been.
Of course, this is part of the teamwork. Actually, when they start the actual project work from the third week, like around 7th of June. So everything they need to link with DFMA analysis also. So that's the motivation of their training. So yeah.
Okay, that'll be very nice. So guys, in the interest of another 1 minute around this idea of the exercise, you can, as I said, you can add notes, you could add your sketches through the thumbnails. If you have the energy and bandwidth, you'll do 2-3 iterations of this proposed recommendations for new product design, and you will substantiate it with writing your notes on this. If you further have the time and the energy, for each of these components, you will also do maybe 1 or 2 critical components. You could do a DFM analysis of the part by selecting the right or what you think is the right material for making that component. maybe one or two components, maybe the base part, maybe one of the components. I'm not expecting you to do all of this. Yes.
Yeah. Mr. Syed, they have question that do they have to upload the DFA file or the report generated as a submission for the exercise?
I think a DFA submission would help to review. Otherwise, I mean, of course, you have so many candidates. So
yeah. So I think
I'm not sure how the validation is going to be.
So I think we can because we will float a Google form for them for each assignment, so they can submit both the DFA and the report generated, so that we can browse it. I will put my PhD student teams for evaluation. That they can do.
Sounds good. Sounds nice. So that's about it for today, ladies and gentlemen. If there is any question they'd like you to ask, this forum is open for the next 7-8 minutes for doing that before we conclude for the day. Now, this software can be operated by anybody who has an idea for a product of Bagul and wants to validate around that idea from a assembly and a manufacturing perspective. You can't import a CATIA part file. You have to export it out as a STP IGS. Balaji, Yogesh, I request you to unmute yourself and see if you can answer some questions on the chat box simultaneously.
We have to export it as a STL step IGS format.
Right. Any other questions, or are we either the silence is giving me a good feeling that everybody has understood everything, or like?
Yeah, guys, you have like 3 minutes and 20 seconds to solve your question, solve your queries quickly. Yeah, I think it's got really good exposure. So
Okay, so thank you so much again for being with me this morning, and look forward to you all having a great learning journey ahead, and we look forward to your feedback forms and DFA reports eventually. Thank you, everybody.
Thank you, Mr. Syed, for wonderful sessions. I think it's going to go a long way for really students to understand the role of DFMA analysis in product development, and I'm sure their colleges will also be looking forward to this tool.
Thank you so much, Dheeraj, for the opportunity and your team.
Varinder, can you unmute yourself? Your voice is coming.
Thank you. So I'll take leave then with the bidding adieu to all of you here, and with a note of thanks from myself and my team, Balaji and Yogesh, who helped me to put this together, and wish you all a good learning journey ahead.
Yeah.
Thank you so much, sir.
Thank you,
for your
Varinder.
precious knowledge. And I'm sure this will definitely help our interns in the coming future. Thank you so much, sir, for your precious time.
Thank you, Varinder. Thanks again. Bye.
Bye, sir.
Bye. Have a nice day.